Hi and welcome. This video is going to be just a quick build on one of my charge controllers. It's called the PWM5 Pico. It's a redesign of Julian Eilett's PWM5 that he used to sell on eBay. It was quite popular, I think. A while ago he released the firmware to be able to build these things. I asked him if he wouldn't mind me making them. He said no, go ahead. He has no interest in making them himself, and I thought I would start making them. I initially did 10 slightly larger ones for my own use, and then actually having to order the components in bulk, I ended up with lots of spare parts. So I decided to put a few on eBay, and they sold surprisingly well, and I've been selling them for about a year or so now. This one is, I've called it a test kit. It's a new, or I should say a different manufacturer of microcontroller. It's a PIC 12F683 loaded with Julian's firmware, but this actually, I have been using clone microcontrollers, but this is actually a genuine PIC microcontroller, so I'm not expecting it to explode or anything silly. I'm expecting it to work as it should. I have had a few clones where they don't work correctly. It's like the analog to digital converter isn't working. So before I release the latest batch of kits with this new chip, even though it's a genuine chip, I want to make sure that it actually works as it's supposed to. So I thought it would be an ideal opportunity to assemble the charge controller on camera. I'll probably skip a few bits and pieces. It's pretty boring watching somebody solder surface mount components. It's been done hundreds of times on YouTube. So I'll do a brief overview, some little intricate, interesting bits and pieces that this particular kit needs. And I shall go from there. I'm using the last of my version 2 boards. I'm now using a version 3 board, which is in a rather fetching kind of purple silk screen. I haven't got one here to hand. 1 second, I'll go and get one. Right, this is, well, it's a panelized boards. I think there's 1, 2, 3, there's 20 on here. More than 20. 2, 3, 4, 5, 6, 24. So there's 24 boards on here. They're just panelized together. It's cheaper to get them like that. This is now the version 3 board, this blue one. This is the version 2. They're identical. The only difference is colour, obviously, and I've enlarged the hole here, the cable holes. These would take a 15 AWG cable, a 16 AWG cable, just 1.5 mil. You really had to twist the cable tight to get it through. This will take the same size cable with ease. So I've just done that just to make it a little bit easier to thread the cables through. Other than that, they're absolutely identical. I think the size is identical. Yes, it is. It's identical. I don't even think I changed any of the positions of the components on it. I think I just get them the same. Just change the colour. But that's the version 3 board. That's now what goes out with my kits. I've got several hundred of those. But this build is going to be on the version 2 board. I'm actually using it for a project, a solar charge project here in my workshop. So I'm basically gathering together all of the versions of my charge controllers and feeding each one with its own solar cell, and then I shall feed them all into a big SLA battery. But yeah, this is just something I need to do just to make sure that the the new PIC is working, but also it's going to be useful to me at the same time. Now I have a few bits and pieces assembled. That's the circuit diagram. Don't actually need that to assemble the board, but it does have the component values marked on it. What I have been using is this, which is my idiot's assembly guide. These come in the kit. It's got both A and B sides. I've actually just written the component values on so I can just see what they are at a glance. I don't make these all the time, so I can't remember each individual component value, so I do have to refer to it. But I shall start with building the kit now. Right, to assemble this kit I'm going to gather together a few bits and pieces. I've got a magnifying glass which is actually illuminated, doesn't really need it. I've got plenty of light here, but that's just to help with identifying the components as they are quite tiny. They're actually 0805 I think, but yeah, reading the writing is pretty awkward sometimes. I've got some flux, always handy. I'm using a generic cheap, this actually is a Katsu soldering iron or soldering station. It has hot air and, you know, the standard kind of Chinese-y, I forget what it's a copy of, but it's a copy of somebody's. I'll use that. I use I think it's about a 1.2mm tip for surface mount. It's very small, so it's designed to get into all the little places, which is quite handy on a board that is so densely packed. And you can actually see how small it is. These squares are about a centimetre across, so it's you know, I think it's 22 by 15 from memory, 23 by 15, something like that. It's quite small, so yeah, you need quite a small iron to be able to get to all of the components in here, because they are very, very densely packed. What else we'll need? We will need some tweezers. I use these needle points, perfect for this sort of stuff. Flux, I've said that already, and standard leaded solder. Can't be doing with this lead-free rubbish. Leaded all the way. It's completely harmless. There's all this jargon about it's going to kill us is all a load of old rubbish. I've been using it for 40 years almost and never had a problem. I'm still alive. So yes, it's all a bit of a story. Right. I'll use blue tack as well. It's nice sticky stuff. It's brilliant for holding the board in place while you're soldering it. Nothing worse than components skating all over the place when you're trying to solder them down. So this is how the kit will arrive. It won't say test kit all over it. It will say programmed PIC on the label on here. It comes in a bag. The PIC micro is here. I'll leave it in the bag for a minute, as that will actually be the last thing to be soldered down. There's all the other components. It comes with a diode which can be put in the solar input panel. Would go this side, charge controller this side. It's designed so that should the panel leads be shorted whilst the charge controller is connected to the battery, the current won't pass up through the body diode of the MOSFET and then straight to ground and blow the MOSFET, which of course is what can happen. So I strongly suggest that goes into the lead, unless there's no chance of it being shorted. If you're using MC4 connectors, then obviously you've got no chance of it shorting, so in which case there's no point in including that bit. I'm not going to use it for this particular kit build, but what I am going to do is get on and start assembling it. When I'm assembling small boards like this, I like to start from the center. On this particular board, the LED is right in the middle of the board, right here, so I will start on that one first. and then I'll kind of work my way out, assembling the bits and pieces as necessary. The LED it's a 1206, it's tiny, but on the bottom there's a tiny weeny little arrow. Now the arrow is pointing towards the cathode. You can't see the arrow, it's a little green speck. Now that goes towards the cathode, and the cathode on this particular board is on, well, it's on the ground side. That's the ground rail there. I've reversed the diagram, so it basically, the microcontroller feeds the LED directly, then the LED has the resistor, the dropper resistor, it's 150 ohms on its cathode, which is an unusual way of doing it. It works perfectly well. It's going to sync its current to the resistor rather than source it from the resistor. It makes no difference to the way an LED works. It's an LED at the end of the day. So that's a little unusual. Other than that, the circuit here is just fairly simple, just bits and pieces needed to do the job that they're doing. What I tend to do when I'm doing surface mount is just put a small amount of solder onto one of the pads where the components are going to be. I just find it helps stick the component into position while the other side is soldered in. So this is the way I've always done it. So on this side I've just put a small amount of solder on one of every component's pad. So then all I need to do is to get the component, make sure it's around the right way, so cathode is that side, just lay it into position, reflow the solder again, and then the component is mounted to the board. And then swing around to the other side, just put it there, and then just a quick touch back again that side, and that's it done. That one is soldered into place and ready to move on to the next component. Right, I've moved on a little way. I've put Q1 on and the two 47 nanofarad capacitors for the charge pump. And I'm just about to put the voltage regulator on, and I'm also going to put the 3 tantalum capacitors on and the transorb, and then this side will be finished, at which point I'm going to just test to make sure that the 5-volt regulator is outputting 5 volts, which of course it will do, but I just like to test it anyway. So I'll just give it a little bit of flux and I'll stick it on. Right, I'll just point out that the 3 capacitors here, these 10 microfarads on those 2 and 1 microfarad on those, these are tantalum caps, and unusual to capacitors, tantalums are marked on their anode, so the line is on the anode, the positive side. Normally capacitors, electrolytics, are marked on the cathode, but tantalums are the other way around, and you don't want to get these wrong, because tantalums can be, well, they get upset in quite a volatile way, a bit like a miniature lithium ion cell going bang. They are quite explosive if you put them around the wrong way. So I just thought I'd better just point that one out. Right, that's all those back on, all the capacitors back into place, the only thing left on this side is the transorb, which is this little device here, or quite a large device. It needs to be big. Apparently it can sink 600 watts. I suspect that's for only a nanosecond, but it's designed as a transient suppressor, so it'll should there be a high energy, well, just not a lightning strike, it wouldn't take a lightning strike, it would just explode. But say a nearby radio station or a police car broadcasts, and your solar panel wire would pick it up, then it could theoretically upset the microcontroller by feeding some power back. So this will clamp at 33 volts. It'll begin to clamp, this one, and like I say, up to 600 watts, although that will be for a very short period of time. So I shall just solder that one into place now. Incidentally, these are non-polarized, so you can put them either way. Right, that side is now done. Don't know if I can magnify it anymore. Not really, it's all full of... No, it's assembled. I'll just flip it over. I'm going to start assembling the other side, but before I do that, I'm just going to check that I got 5 volts between pin 1 and pin 8 on the IC. Right, I had a bit of a brain fart. The input is protected by D2. It's a dual diode, and the input has got a reverse polarity protection. So, of course, unless you actually have that in place, there's no power. So now that I've got that soldered into place, I've got 12 volts on the battery terminals, or on the battery plated through holes. So on pin 8, which is the ground, the neg of the microcontroller, and pin 1 should show 5 volts. And we've got 5.04, so that is working as it should so far. So on with the build. Right, all of the passive components are on now. A crude magnifying glass. The microcontroller is the last component to go in, which is here. Like I said, this one is a genuine Microchip PIC. My other kits I've actually contained, the ones I supplied were clones. They worked, but I've been bitten by some clones recently, so I decided to switch to genuines. I mean, it pushes the price up, but because I've managed to make a saving on the board by panelizing them, getting them in bulk, it kind of offsets the cost of supplying the genuine PIC. So that's what I shall include from now on. I just need to make sure that the code is taken in the genuine PIC, and the charge controller does as it's supposed to. So I'm just going to solder that one into place now. Right, the PIC is in place. I've left the MOSFET off for a minute. I'm just going to do a quick check on a voltage sweep to make sure that the PIC is responding as it should. I'm just going to use my bench power supply to do that. I'll just apply power, battery voltage, nudge it up to the point where I can see the LED doing its modulation, which should be around 13.5 volts, give or take a couple of tenths of volts. Generally before 13.8 it'll be modulating. Sometimes it's bang on 13.5, but normally it's a little bit high. Just seems to be the way the code works, and slight inaccuracies in various components. But lead acid batteries are quite happily at 13.7, 13.8 volts anyway. So I should just power this one up now and see what I get. Right, I should just power it up. My bench power supply is set at 13.6 volts, so we'll see what this displays. Right, 2-second boot up, and then it's gone straight into modulation. So actually it's showing modulation at 13.6. I'll see if I can nudge it down a little fraction. My power supply is always very jumpy. 13.5 volts, yes, so it's really right on 13.5 to 13.6, so that is modulating absolutely as it's supposed to, which I'm quite pleased at. So that means this chip is working as it should. Right, 13.4 volts now, so it should give 3 longer flashes and say 4 short flashes. 1, 2, 3. 1, 2, 3. Fairly close. It's 1/10 of a volt out, but that's good enough as a visual indication. Now that I know that the circuit is working as it should, I'll assemble the rest of it, which actually just is putting the MOSFET in. Now, to put these MOSFETs in these boards, it fits above the microcontroller. It lays above like that. So in order to get it like that, you actually have to fold the MOSFET right at the body. So what I tend to do is just lay it flat and just twist it over so that the legs are absolutely 90 degrees to the body, nice and tight, and then it just assembles into there like that. I tend to hold it right above the component like that and then just solder it in. It doesn't matter if it's slightly above. The MOSFET doesn't really get hot in operation. It might get a couple of degrees above ambient, but not very hot. Sometimes it's just helpful just to lift it off very slightly, so just a piece of plastic or cardboard, and then just solder the pins. I tend to use crocodile clips just to hold it into place, which seems to work quite well, and it'll do the job. And that will be one assembled charge controller ready to install on my power wall. And there she is, soldered into place just above the MOSFET. MOSFET is just above the microcontroller. All it needs now is pins cropped off, the leads put in, and put it into action doing the job it's designed to do. So there you go, that's a quick assembly on the PWM5 Pico that I sell as a kit. It's very small. I find it fairly easy to assemble, but it depends on how much surface mount experience you have. But it certainly will do exactly what it's supposed to do. Thanks for watching.